This lesson is focusing on how to create a histogram and a frequency table, and then how to interpret the data that you see presented in it. So let's say these are our data pieces. A frequency table is a table like what you see below. It has 3 columns: 1 interval, 2 tally, and then the third is the frequency. Intervals, that's probably the hardest part. In order to determine the intervals, you need to look at your numbers. So if we're looking at our numbers, looks like our smallest number on that list is 1, and our biggest is, 18? So we need to go from 1 to 18. It doesn't make sense for me just to have my interval be 1 to 20, because then every one of my data pieces is in that interval and you can't see change. So I want to have at least a couple of intervals in my data in order to be able to see the difference between the data values. So I only really need to go from 1 to 18. So I chose to go by 5s. So my first interval is 1 to 5. My second then is 6 to 10. The next is 11 to 15, and the last is 16 to 20. Notice that none of my numbers repeat, like 5. I don't have my first interval being 1 to 5, and then the next one being 5 to 10. The intervals are the same size. They're all 5 numbers, and then they're all consecutive, meaning in order, even if I don't have any data pieces in there. The tallies and the frequencies kind of say the same thing. The tallies, you go through your pieces of data and you make a tally for each one where it fits in a particular interval. So like the first one is 9. So I would make a tally in the box for 6 to 10 because 9 is between 6 and 10. And I would go ahead and do that for the rest of the pieces of my data. The frequency is just basically an easier way of looking at the tally column, because it's easier for me to look at it and say 6 than to have to go through and count all the tallies. To make this data in a histogram, you need 3 things. You need 3 labels. The title of your graph. We notice these are just data pieces, so I don't have necessarily a title, but it says title of graph. And then the bottom is your intervals. And then the y-axis is always labeled frequency. The y-axis is always going to be labeled frequency because it tells you how many. So really all that you have to focus on is your title of your graph, which has something to do with what your graph is talking about, and then your intervals are whatever your intervals are regarding. And I have my intervals 1 to 5, 6 to 10, 11 to 15, and 16 to 20. A histogram looks very much so like a bar graph, with the exception of it has the intervals at the bottom, not singular numbers or categories, and then also the bars in a histogram touch. So because my intervals are consecutive, the bars touch each other. So my intervals are 1 to 5, the next number is 6 to 10. So 5 it comes directly before 6, therefore my intervals touch. So I have 6 numbers that are between 1 to 5, so my first bar goes up to 6. I have 6 numbers again that are also between 6 to 10, so my next bar touching the first bar goes to 6, and so on. If I do not have any values in an interval, if my inner value is 0, then I would just leave that section blank and then draw my next bar touching the blank one. So if we take a look at this one, this was the ages of the senators that began the 112th Congress on January 3, 2011. If we create a histogram for the data set, we first have to look through what our numbers are to create the interval. So it looks like my smallest number in the list is 39 and my biggest is 86. So we need to basically go from 39 to 86. So because to keep it easy, I decided to go by tens. So I went from 30 to 39, 40 to 49, 50 to 59, etc. Those are all spaced by the same amount of numbers, 10, and they're all consecutive, meaning there's no holes or gaps between the numbers. I didn't put the tallies in the chart only because there are that many, but I did count how many, so I do have the frequencies. So technically you would have to have the tallies in there as well. But to save time in this video, I did not count them all and put the tallies in the table. So if we're looking at this histogram, I have my titles at the top, ages of senators. I have my intervals at the bottom. In this case, we should label them ages. And then I have my frequency, or how many in each category, on the y-axis on the left. So I have each bar drawn to the height from the table that we just created, and they are also touching. So just like with the box and whisker plots or the line plots, we can talk about the data distribution. This data distribution is approximately symmetrical because they're, for the most part, look symmetrical, and there are no data pieces that stick out very far from the others on either the right or the left. Okay, then there are some things called possible ranges. This is a little bit different from the range or the interquartile range that we found before. So if we're looking at the possible ranges, the first one says the maximum. So the maximum range, remember, is the difference from the maximum minus the minimum. So the maximum range takes the value of our last interval, that's the highest, so that's 89, and our value from the smallest interval, the smallest value of it, which is 30. Because histograms, just looking at those without the data table, you cannot tell what exactly the data pieces are. We know our data is somewhere between 89 and 30. So our data range, the maximum range, is 59. However, our minimum range, we could do the same thing except take the minimum value that's in the upper interval and the maximum value in the lower interval, and we could subtract them as well because we still have data pieces in there. And those are the highest or lowest numbers that a number could be to be in that particular interval. So that would be my minimum range. The other thing that you can estimate from the histogram is the mean. Because you don't, again, know the values, you just know that there is a data piece in between that interval at some point. You have to use that to kind of estimate what the mean is. So if we're looking at the intervals, again, we had 30 to 39, 40 to 49, 50 to 59, etc. So we want to use the midpoint of the interval as a substitute for each value. So if we're looking at the interval 30 to 39, 35 is the middle or the midpoint. 40 to 49, 45 is the middle or the midpoint, etc. So in order to find out the median, or the mean, you need to take the values that are the midpoints and multiply them by the frequency, or how many are in that particular interval. So the first midpoint we had between 30 and 39 was 35. There were two numbers in that interval, so we took 35 and multiplied it by 2. The next midpoint we had between 40 and 49 was 45. So we took 10 because there were 10 numbers in that interval and multiplied it by 45. And we did the same thing for the other 4 intervals. Then we added them together, because remember, in a mean, you add the numbers together and then you divide by how many there are. So we added the numbers together and we got 6,180. And then in a mean, we divide by the number of numbers you added. There were 100 senators, so we added 100 numbers, so we divided by 100. So that would be 61.8, or approximately 62 years old. So the mean, or the average age of a senator in that particular group, was 62 years old.